Hi, I'm Fabrice Harari. Welcome to WinDevCon 2007, the Art of Debugging course. We're here to talk about how to use the debugger, trace, log on your newly optimized code. Debugging your customer application on site is going to be also part of the subject. We should cover this topic in about 3 hours. First, what is debugging? Let's try to define what it is. This way we'll be sure we are talking about the same thing. It's not simply using the debugger. It goes much further than that. So, how do you debug? Well, first you write the code, and then you test and make it work. All that process is debugging. So, when does debugging start? Well, obviously, you know it now, but there's a problem. Debugging starts in fact before you write your code. So now you think I lost it. I just told you that debugging is when you test and make the code work. That cannot be before you write the code. Well, let's see. What is debugging? Now you're sure I lost it and my presentation is in a loop. I need to debug it. Well, I'm not sure about that. Debugging is really done in 2 steps. First you define what the code should be doing, and then you find out what the code is really doing. But it just happens that the first part, defining what the code should be doing, is something that you should do before coding. It's when you write the algorithm, and it's already a part of debugging. If you don't know what the code should be doing when you're writing it, there's a very good chance that you're not going to write a very good code, which means that it's really something that you should define first. So okay, there's not a lot of people perhaps who are still doing algorithm the old way, on a paper, on a whiteboard, and before they code anything. Perhaps for the complex thing, but for the things that are really straightforward, you just start coding. It's very easy in WinDev. Well, if you do that, you have 2 problems. First, when you code, you don't know exactly where you're going, so you're going to lose a lot of time. And 2, when something is not working, you have nothing to refer to and to know what you should be doing. In fact, it's a trap that is very easy to fall into. So I devised a simple method that combines in fact the power of WinDev by example and the old way of writing algorithm. When I want to code something, I first code this. You see, in fact, what is the algorithm written as comments in what is going to be my button in the WD slow example. So what did I do? As you can see here, I said okay, I have to create the files empty, then here I have to start to count the elapsed time, then I'm starting my first loop on the creation of companies. Immediately I'm writing the end of loop on creation of companies, and inside the loop what am I doing, and so on. Same thing here for the second loop. It's the optimized version of the code, of course, that we are talking about. So you see I have all the commands, and all these commands are in fact the skeleton of my code. So as soon as I start coding, I start to add code in my algorithm directly inside it. And here's the result. Create the file empty. Okay, here's the initialization of variables that I create when I need them. Then start to count the elapsed time, and so on. As you can see that exactly between my my commands you have all the corresponding code. Which means that when I have a problem, when something is not working correctly, well, I just have to look at the commands and I know what I wanted to do at the beginning. So that's what it should be doing. Well, it could be also that I didn't know what I needed to do at the beginning and that my commands are the problem. In that case, I have to redefine what I should be doing. But at least I know what I wanted to achieve when I write that code, and if I have to come back in 6 months and debug that code because I finally found out that there's a bug in there, well, I will still be able to tell what I wanted to do at the time. And perhaps I will say, okay, well, that's stupid, that's not what I should have done. But at least I know that that's what I wanted to do, and the corresponding code match or doesn't match what I wanted to do. Okay, now that we know that the debug period in fact starts before coding, let's see how you should code in order for the debug to be much easier. By example, don't do this. If condition, then do something else on the same line. Instead, do if condition, then on the second line do something, or eventually on several lines, of course, else on another line do something else. And when you're going to debug, you can inspect easily the content of each line, but if your line is extremely long and complex, you won't be able to see anything. The same way, don't do var z equal parenthesis var a plus var b close parenthesis divided by var c multiplied by var d close parenthesis minus var e. That's nice, of course. You can put 250 different calculations on the same line. It's really nice. Well, except when your calculation doesn't work and you have to find out why, because you won't be able to see any result calculated inside the line, just the end result. Instead, if you do this and that and that and then that, you're going to be able to see very easily when you inspect the content of var ei on each line what is going on. If var I is not the result that you expect on the first line or the second line, you know that your calculation is wrong there. So you can really understand what's going on and solve the problem. One very good example of this kind of problem is when you assume that the type of the variable inside the calculation is going to be this or that. And it's just you assuming. You don't know how the compiler on the other side is going to consider the value it's working on, and if it's going to use integers, real currencies, or whatever to work on. So what's going to happen with the decimals, you don't know. If you do that step by step, you're going to see if something is not what you expect, and potentially you're going to be able to type your variables, or change the type, or change the way it's calculated, add a function to remove the decimal if you don't want them, and so on, in order to have the result you want. So you have, when you code already, you have to think debug. Don't believe, I was talking about the assumption about the type of variable in a calculation. That's one assumption that you're doing. The same way, very often people assume that the order of calculation when you have complex calculation or condition is going to be this or that or something else. You don't know that. So if you assume things like that, you're going to be in trouble very easily. So when you code and when you debug, don't assume things. When you debug something, verify each and every variable. If you enter a debug phase saying, okay, it's not coming from that, I know that that is right, well, you're already wrong. Because, well, perhaps something that you modified in another code made your entry value be wrong, and your code is correct, it's just the value that you're giving it to that is wrong. So verify everything. How are your parameters? How are even the WinDev function sometimes? By example, I was working a few months ago on H function. I don't even remember which one. And I was using this new wonderful syntax where you don't have to put the quotes on each side of the company name. So I had this wonderful hxxx command, myfile, and so on, and it was not working. And when I inspected the code in the debugger, I realized that my file, when I was looking at the value of my file at this point, was 1 instead of company string with the value company in it. So I replaced my code with hxxx company in quote instead of company without a quote, and that solved the problem. And I was able to send a wonderful report to PCSoft to tell them that this was incorrect and that they had to correct it. I have no idea if they did. Probably, of course. So if you assume that the WD function, the WinDev function, will always be correct, well, then you miss this kind of problem and you're out of luck. So just check everything. Also learn when to stop. Your program is running, it's a wonderful loop. Obviously you don't want to debug from the first iteration of your loop to the last one. You want to debug when something is not working. So you have to learn how to put a stop in your loop at the right time and the right place. There are several ways to do that. We're going to look at them. Learn what to inspect. Of course, you don't want to debug your whole project code, so you don't want to inspect every line from the beginning of the program to the place where the bug is happening. You want to inspect the code that is creating a problem, and that, well, the code that you think is creating a problem. And if you end up saying, okay, that code is correct, it's not creating a problem, it's the value that is fed to that code that is incorrect, then you're going to look at the code that is feeding the value to the code you inspected first. And step by step like that, you're going to end up finding where the problem is coming from. So it's extremely important when you start debugging something and you use procedure, method, subroutines, however you want to call them, to check at the entry point and the exit point, do you have the value you are expecting? If you don't have the value you are expecting at the entry point, then you know that something is wrong before that and you have to debug something else. Now, if you don't have the value that you are expecting at the exit point, but the value is correct at the entry point, then you know that your problem is inside that code. So it's extremely important when you debug to first start by finding the beginning and the end of the area that you have to inspect closely. I'm going to see how the debugger works in details. We're going to use a very simple code for that. We're going to use the code used in the faster button of the optimization WD slow project. And we're just going to use that code to inspect all elements, see what we can do in the debugger, and see how exactly it works. Of course, the first thing is to know how to start the debugger. The debugger is a tool included in the main window of WinDev, and you can start it different ways. If you want to debug the whole project, you can go in the project menu, do test mode, trace the project, or also use the shortcut Alt F9. Of course, this has limited use because most of the time you don't want to inspect and debug your project initialization code, so you want to debug only something that is much further in the code, and you don't want to have to read all that line by line. It happens from time to time. You need to do that because you have a problem in the initialization of your project and you have to figure out what's going on. So it can be useful, but most of the time you need something that is much more precise. So you can also start the debugger on the fly. When you're in test mode, you can at any point do a control pause or a control break depending on your keyboard, and that will start the debugger Of course, it will start the debugger if you have some code running that allows the keyboard input to be seen by the system. That's where the multitask comes in handy. If you don't have any multitask in your code and it's running like crazy, there's very little chance that you will be able to start the debugger anytime soon. Of course, it's not very precise. If you do that in the middle of a loop, you don't know at which line you're going to be when you're in the debugger. So it's something that you can use mainly when you want to debug the code starting at the click on a button, by example. So you just do a control pause or control break, and you click on the button and the debugger window shows up. You can also do that directly from the code when you know in advance where you want to have the debugger start. On this line you can either enter the keyword stop or enter a breakpoint by clicking on the left of the line where you want it to stop. You can have several breakpoints like that, and the debugger is going to pop up each time the code meets one of these breakpoints. The good thing about using the stop keyword opposed to the breakpoint is that, well, you can use a conditional stop. By example, in your code you can say, okay, if my variable equal this particular value, then on the next line stop end. Which means that with a code like that you can very easily stop your process if only a value that is abnormal pops up, and whenever it happens, okay, your debugger pops up. So it's something that can be useful, but there are other ways to achieve the same thing. Of course, it depends in what condition you are. So let's debug our faster code. We are now in the WinDev editor with the WD Slow project open, and we are going to first use the first method, debug the whole project. So for that you go in project, test mode, trace the project, and the program is started. Now we are in debug mode. So why do we have this window and not any type of code visible? It's just because in that particular project there's absolutely no code in the project init code or any class initialization or even the window init code. So there's nothing to debug before that. But let's show you what happens if there is. Let's stop that. Go in the project code, by example. And here, so I have my commands. Obviously the debugger is not going to stop if there are just commands in something. But here I have a variable that I prepared for you, and we're just going to uncomment that line. So we have a variable declaration. Let's see the difference. If we do project, test mode, trace the project. Now, okay, we are back here, and you see that now we are in the debugger mode. So you can see debugging here. You can see that you have this toolbar here with all the debugger. Go to the next breakpoint or just run the code normally, stop the debug session, and all the different way to go from one line to the next one or to something further away. So you have all these are your debugger buttons. And you see that here you have this yellow arrow that points to the line that is going to be executed. This line is not executed yet. You also can see the first really wonderful debug feature is that, well, you go on a variable and it tells you that this variable currently value is 0. So that's extremely interesting. And you see, just by declaring a variable, the debugger stops there. But we don't need that variable, obviously, so I'm just going to stop the debug and put that in comment again and just start the program normally. So now we're not in debug mode. We have the window open there, and if I click on create faster, it's just going to do its normal job. So what I'm going to do, you can't see that, but I'm going to do it. I'm going to do a control pause, and then I'm clicking on create faster, and you see I'm on the first line of the button code with this arrow saying, okay, this is the line that is going to be executed, and well, we are going to just debug the whole thing. So that's the second way of debugging something. Now, if what I wanted was just to debug starting from somewhere in the loop, by example, I could do that by creating a breakpoint or using the stop keyword. Let's see how it's done. So I'm going to stop the debug once again and say, okay, let's say that, okay, I don't care about that, creation of the files, all that, okay, that's not my problem. What I care about is the creation of the contact. It's somewhere in there that we have the problem. So I'm going to put my breakpoint here. I just click, simple click in the yellow column, and you see I have this wonderful red breakpoint that tells me, okay, the debugger is going to stop there at the next execution. So let's do that. Run the program normally. And you can see that the code that is before my my breakpoint is run absolutely normally. All the company are created without any interruption. And I arrive here and I see that, okay, I have my breakpoint, I'm on it, and I can start to work on it. So now let's see, what is the value of Imax? 10,000. Oh, we're lucky. We did a loop on 10,000 record add, and we have 10,000 line in the memory zone. So at that point it's good. You may be currently laughing, but if you assume that here you have 10,000, then you assume that this whole code is correct. And while you believe that your problem is in that code, you may be wrong. You don't know where the problem is, otherwise you would have corrected it already. So if you have to debug that code, the first thing that you do is verify that, okay, we are going to do a loop on 10,000, that's what we were supposed to do. So Imax is 10,000, okay, we're going to go into the loop. So I can use this button or the offset key to go to the next line. And you can see when I did that here, this information changed. So what is that? This is the debugger information where you have here the call stack. It would be the list of all the code calling each other. So by example here we're in the button create 5, and we could be calling a procedure doing this and that, and calling another procedure and calling another procedure, and this will be reflected here. Here we have the list of expression and all the value. So myself currently is create faster, it's the name of the button, so that's correct. H error currently is 0, H found is false, H out is true, H rectum is 10,000. Well, that's kind of normal because we just created 10,000 record in an empty file. Imax is 10,000. So basically what the debugger is doing is telling you all the things the debugger think is important. It doesn't mean that you have all the things you need, but you already have some information here. It also tells you that you are in the main thread. And as you can see, I click on this and there's nothing else, so I have only one thread running at the time. So at this point I'm going to retrieve the content of the memory zone for the first line. Okay, scomp is empty before. When I do that in scomp I have one dash. Yes, I'm adding the dash here, so that's correct. Now I'm going to loop on contact creation. Here I have my random 1.5. I have still the source optimization. You see that we are in fact in the source editor. In previous version of WinDev, I'm thinking about WinDev 5.5 by example, you had the debugger window that was a totally different window than the editor. Here it is the editor window that is used for the debug, to the point where you can modify your code while you are in debug mode. I strongly advise against that possibility, except if you want to do just a very small change. By example, you're reading your code and you're saying, wait a second, I'm initializing my loop from 5 to 73, and I should in fact do it from 4 to 72. Let's change that on the fly and see if it works correctly now. Except if you do this kind of thing, it can be more confusing than good to do modification while you're in debug. So here you have the index, and we're going to see what's going on. Okay, so ang index is equal 1. As you can see, you can go on every variable and see what it's giving you. If I'm doing that, you can see that contact equal contact between quotes. I told you once I saw one of these functions displaying the name of my file here, and here I had contact equal 1, and obviously it wouldn't work afterwards. So it's extremely important to always check everything. Now if you suspect that something could be modified by some other code, let's say that you have another thread that could modify things, that you have just a code that is extremely complex with a lot of procedure called from within it, and you don't want to go inspect in details every one of the method that is called. So what you can do is, okay, decide I want to stop next time that the contact ID company is modified. So first you're going to select that, and you're going to add the expression to the debugger, the expression you just selected. Okay, so now I have contact.id company, and it's currently 0. Okay, so now each time I'm going step by step anywhere, if the value change, it's going to be displayed there. Still 0. Oh, now it's 1, and you can see just change, it's in red. Okay, so it changed. Now you also see that you have a stop column. So if you want to stop each time your contact.id company is changed, you just do that, and now it's a breakpoint, but it's a conditional breakpoint. It's going to stop your code only if the value of the expression here change. And when we are talking about expression, it means really an expression. It's not only a variable, but it could be a calculation, it could be a condition. So it's really, if it changes, then you have something that has changed. By example, you could add this. Sorry, let's select this and add this to the debugger. And if this expression change, then you're going to stop. Well, if this expression change, it means that either the name last or the name first change. So just by that you made a test on two different things. Let's try to do that. We have a stop on the ID company, and what I'm going to do is I'm going to click on the go. The go is just going to run the code normally and stop at the next breakpoint, either absolute breakpoint here or conditional breakpoint here. So if I do this, see, conditional breakpoint find by debugger. Details, value of contact ID company expression changed. Okay. And I'm here. So I had a message saying, okay, I stopped because of that. And I see that the value here is 2. And I can work on that. This opened the door to a very interesting possibility. I said that any expression could be, or nearly any expression could be evaluated here in the debugger, and we're going to see that. Now you have an expression here, and you can modify it directly also at this point. So if I go in here and right click on it, I can do edit the expression. And by example, I'm going to go at the end of this one and say equal 587. 7. Okay, what does that do? Well, in fact, I just created a test on the value of ID company, and my debugger will stop when ID company value is 587. So when you're looking at your program and your program is adding things in a table and suddenly crashes, well, one of the things you can do is look at what is the last line or one of the last line that was added before the crash, and add an expression like this one, a Boolean expression, and just run the program till that point and inspect everything at that point. At that point you will see if it's a specific value coming from the file or a specific case that creates the problem, or if you don't see anything specific at that point and it crashes, perhaps it's just coming from, well, another problem, and it's an accumulation of problems that make it crash there. But at least you have a way to stop when any variable is equal to any value, and we're going just to run that and see how it works. So here the program runs normally. You see we have the go button that is gray while it's running, and you're going to say, okay, but we can't see anything. Well, obviously I cannot record that very easily, but one very good way to use the debugger is to use a dual screen setup. When you're using a dual screen setup, you can have your program visible on one screen and the debugger visible on the second one, and you can pass from one to the other very easily. Also, I could pass from one view to the other by Alt-Tab as with any other program, but you have to remember one thing. If you put some code in the lose focus or gain focus section of the window of your program, and you do Alt-Tab to reach it, you are going to gain focus or lose focus, which means that this code is going to try to fire while you are trying to execute another code. So that's not going to happen. You're going to have a problem at that point, and that's one of the limitations of the debugger. So that's why having a second screen is a very good idea to do that, because, well, you can see what's happening on the other side. You don't touch anything, you just go in your loop and all that, and when you end up a section of code and your code is naturally giving the focus back to your window, then, well, you can start something else and you will be in the debugger. It's the good way of doing that. If you don't have a dual screen setup, I would suggest that you buy yourself a second screen. It's a very, very good investment. But if you don't do that, remember that you can also reduce the size of your debug window and see at least part of your application screen in the remaining part of the window. Well, here what happened is that we just have this conditional breakpoint that was found. The value is 587, and the debugger just stopped there. And here we have this ID company is 587. As you can see, we still have the contact name last plus contact name first, and it was before 586-2 and so on, so it's perfectly normal. Now let's have a look at some of the other tools that are available in the debugger and that can be very useful. You already saw that you have here a number of buttons and available. It's one of the regular toolbars, but you also have them here in the debugger pane. This debugger pane is available even when you're not in debug mode. In the in this pane you already have access to it. So that means that you can, while you are preparing to test something, you can come in the debugger and here add an expression like contact ID company equal 587 and just start your program normally, and it's exactly like putting here a breakpoint. So you just put your value here, click on stop, and when your expression is going to be true at any point in the program, you're going to stop. So it's a very easy way to stop somewhere in your code if you have an idea of where and what happened. As you can see, you have the same button here than you have on top in the regular toolbar, so we can watch one or the other at the same thing. Here you have a button that allows you to view an expression. That's really interesting. By example, here you can't really see what's going on, so if you select it and just click on here, you see, okay, the whole thing is that value, and you can have a multiple line value and inspect it. You can also do that when you're not on an expression, and just do that. Type your expression, by hand. For example, I'm here and I click on this. Still okay, I'm still on the same thing. But you can enter another expression and have the value evaluated on the fly if you don't want to put it in the list of the expression. This button is to view the status of data sources. It's extremely interesting. Have a look. Here, what do I have? Okay, I have the two files declared in my application, the company and contact, and I can see that the current status of the company file, okay, here are the three fields of my file, value 10,000, the name and the city, and if I go in contact, here is the value in the contact file. So I'll have a current record of each file inspector available here directly in the debugger, very, very easily. So that's really great when you want to find out what's going on. Are you on the correct record or not? You can see it immediately. Another thing that is extremely interesting here is that button. You see that it's a toggle button and it's currently on. If I remove the toggle button, look at the list of expression. Okay, you see that several lines just disappear. I'm going to put it back. And what are these lines? It's contact and an index. So, okay, so what are these? These are the expressions that are automatically added by the debugger depending of where you are here. You see that we are on this this line. So on this line, automatically it's going to say, okay, contact value is this, because I think it's important and I know that the ID company I'm working on is from the contact that is in fact contact. And the index that is used on the line is 587. So at this point the system find out that these two information are important, and if the auto button is on, then the information will be available from you automatically. If I don't want that, just remove it. The same way here I have the hyperfile review. If I uncheck that, all the value of the hyperfile variable are not visible anymore. Now here I have the local and the global variable toggles. If I do this, all my local variables declared in this process are here. If I do that, it adds the global variable. I don't have any in that program, but you can inspect them very easily. Of course, you could just type the name of the global variable in the expression, add an expression, and you would see that particular one. But if you want just to toggle on-off quickly to inspect a few things, it's very easy to do. One interesting thing that you can see here with the local variable is these two variables, time1 and time2. When I see that, I have a reaction saying, oh, wait a second, I put the time1 in place. Yes, I did. It's somewhere over there. But yeah, it's here. But I didn't put the, sorry, no, okay, that's not good. Let's see, what did I do? I'm going to cancel it. Here we are. Okay, so I did initialize time1, but I didn't initialize time2. Why is there this value in it? Well, it's because a time variable can only contain a time. An empty string is not a valid term, so when you declare a time, it automatically takes the current time as its init value. And it means that if you forget to do here this time2 equal time6, you're going to calculate with a wrong value. So it's an interesting thing to see and to verify that it's really what you want to do. So now let's see, where are we? Yes, so we have that, this, and yes, show the W language review. If I remove that, okay, I'm going to remove that before because I can't see anything. I'm going to remove this too. Okay, here I have myself and I don't have it anymore. So that's in fact the toggle to show all the regular W language keywords and have them visible or not in your expression editor. On this side you have this button. It's also extremely interesting. I'm going to press it and you can see immediately all the strings are visible in hexadecimal form. Okay, we did a tour of the main feature of the debugger. It's a really great tool to find out what's going on in your program. Of course, the tool by itself is not going to tell you the bug is here with a red arrow flashing on the line or even on the snippet of code that is the problem. So it's going to be your job. I know it's sad that the debugger is not able to do that, but well, that's perhaps the reason why we still have a job. So you have the tool. How do you use it? Well, the first thing to do is to make sure that the bug you are working on is reproducible. If it's something that happens from time to time, you're going to be very hard pressed to find out what's going on. If you cannot reproduce it every time you run it, then you have a problem. Also, you have to remember that the debugger works only in test mode. So if it's a bug that happens all the time at your customers but never at your place, well, either you go over there with WinDev, install it and try to run the program in test mode, or well, you're out of luck because you cannot use the debugger. We're going to see later on how to debug at your customer without the debugger, but it's going to be much more painful than what you just saw. So let's say that you're able to reproduce the problem every time, you know how to do it. Now you have to find out where it's coming from. And for that we are again, like in the optimization process, we're going to work by elimination. Of course, first, in what function of the program do the bug happen? If it's in the billing function, you're not going to go debugging the accounting first. You're going to go debug the billing code by itself. It doesn't mean that the bug is going to be where you think it is. Again, remember that the entry value of a variable can be the cause of a problem somewhere. if you build a code saying, okay, I'm going to receive as a parameter the name of a file, the unique key of a record, and a third value, that is the value that I have to set in the record. Well, you build your whole code on the assumption that you're going to receive these things and that they are going to be what you expect. If what you receive is not the unique key of a record that you're supposed to load in order to modify it, but it's instead either the value of something else, you're not sending the right key value, or you're just sending the value but the key is not unique, then of course your code is not going to work. And that is because your code is built on assumptions, and these assumptions are not true. So the first thing to do when you are looking for a bug is to check everything. Your assumption should be written. When you write a method, you should have at the beginning of the method, okay, I'm supposed to receive this parameter, that parameter, that parameter, and this parameter is supposed to be this, this, and that. If you don't have commands everywhere in your code, you're not going to be able to debug very easily. In fact, it's going to be very hard to debug. So remember to comment everything while you are writing the thing and not afterwards. I heard so many times, oh, I'll write the code first and then I'll write the comment after. Well, first, it's not going to happen. And second, well, it means that the whole debug phase to make your code work, you won't have the tool that you need to do it, which is absurd. So comment first, write second. That's the way to do it. Now, if the first thing that you do is to look at, okay, what do I have when I enter my code? Are my parameters correct? Are my assumptions correct? The second thing that you do, if you think that a bug is coming from the code that you have there, is to make sure that the bug happens while you're in that code. So you should make sure either it's a visual bug so you can see it easily and okay, it's during that code that it happens, no problem, or it's something a little more subtle and you think it's coming from there. So you have the return value of this function that you think is going to be wrong. So the first thing you do, check the entry value, let the whole code run and check the exit value. If the exit value is not what it should be, then you know it's something between this and that. Once you've done that, well, you have to repeat the same process for each logical step in your code. You really have to see your code as a series of action, and after each action, do you have what you are supposed to have? And sometimes it's a little tricky to find out because okay, you got 23,000 records in memory. How do you check if they are the right ones? Well, sometimes the debugger is the answer, and sometimes it's more using traces and things like that, where you are going to look at the content of your code more in depth. So basically your mindset when you are debugging should be the mindset of a policeman trying to find who did it. And you're looking for clues, and you really should be in this, okay, I have to find out clues about what's going on. I have really no idea. Somebody is messing with my program and I have to find out exactly who. That's really the way to look at it. Of course, I've seen a lot of people saying this stupid thing is not working. Well, that's not the right mindset either. You are the one who built the stupid thing. So if it's not working, it's because of you. So really take that more as a game than as a burden, and look at it as okay, it's It's a brain teaser. I have to find out what it is. You're going to find out that it's much easier to do if, well, you take it a little more lightly. So now that you know how to use Debugger, let's see how to use it. And it's not the same thing, of course, because now we are talking about the big picture. How are you going to put yourself in a position where the Debugger tool will be useful to you? So, the first thing that you have to do, of course, is to reproduce the bug. If you're not able to reproduce a problem that a customer sent you, there is no point in trying to debug it. If you don't have the bug, you don't have the problem, you can't find a solution. That's also the reason why PCSoft insists so much on us giving them the exact reproduction protocol to have the bug each time, because if they are not able to reproduce the bug, they won't be able to look for it and debug it. That's a given. So I've seen so many times people complaining that PCSoft is not answering correctly in the support system. Well, I think that they're doing a pretty good job considering the complexity of the products they are selling and the difficulty to reproduce a problem. Most of the time when you see the message that somebody is putting out for the bug description, it doesn't mean anything. So if you have a problem, reproduce it. Send them with a project example. And if a customer sends you a bug, you will want the exact same thing. You will want to know exactly what the guy is doing. So once you know how to reproduce the bug, you will have to also see if you can reproduce the bug in test mode. Sometime, not all the time, and that's a good thing, but sometime a bug happens only in executable mode. Because again, the test mode itself will introduce a few differences in the way things are done. So if you are able to reproduce the bug in test mode, you can use the debugger. That's a very good thing. If you can reproduce it only in executable mode, then you will have to rely on alternative methods to find out what's going on. Then you have to isolate the bug. And for that, one method is to comment the calls. What calls? Well, any calls that you don't need to reproduce the bug. In a process, any type of process generally, you are calling this method, or this procedure, that procedure, that WinDev function, this WinDev function all the time. That's what you're doing. Well, once you know that the code is between this line and that line, try to comment out part of the code. If you comment out part of the code and the bug is still there, you know that it's not in that part. Well, at least you know that the bug itself is not in that part. Perhaps the reason for the bug is coming from somewhere else. So by doing this kind of thing, you're going to isolate little by little where the bug is coming from. If you can, try to reproduce the bug and to do that outside context. Remember all these problems that we have that are or are not dependent of everything else that we are doing. So if you can take the code that you're using and just extract it from there, put it in a small project alone. If the code is working when it's in a small project alone, you know it's not the code itself, it's the context in which the code is executed. It's the value in entry that are not correct or are not what you are waiting for, at least. An example of that would be that you think that at that point the current record in the company will be this record. It just happened that you're doing something somewhere else where the company is, well, not that one. The company is empty, and therefore you don't have what you need to do what you want to do. So if you can try your code outside of the context, then you can isolate this kind of problem.
If it's not already done, and it should be, write down assumption. What do I call assumption? Well, when you are coding a procedure or a method, you are supposed to write in the header what the parameters are, what they are for, and what they're supposed to contain. Well, that's one thing, but also it's perfectly possible that you rely on things being in a certain stage. The example I was giving about the company being this or that is one of them. You shouldn't. You should only rely on the parameters that are sent to you. But I'm afraid that very often we do rely, voluntarily or not, on the fact that something is in a particular stage. Well, if you don't write down all the assumptions that you're making when you're coding something, then when you come back to debug, you don't know what is supposed to be what. You don't know that this file is supposed to be closed, that file is supposed to be open, that this is supposed to be this way or that way. And some of this information is extremely relevant to the debug process. So if you didn't write the assumption when you wrote the code, now is the time to do it before you start debugging this particular portion of code. Again, if you didn't put your algorithm inside your code as comments, if you didn't write with all the commands what the code should be doing before you start debugging something, the first step is to say, okay, what is this thing supposed to do? And write it down as comment. If you didn't do it during the coding process, that's bad. But if you don't do it when you try to debug a code, that's worse, because at that point you will have no idea what you're doing. You will rely on luck only to find the problem. So that's the at least moment. At least do it now. Write down all the commands. What is the code supposed to do? Then, once all that is done, you've prepared your code for debug. Verify entry values and exit value. How many times do you have a method or a procedure where you're supposed to have a company code inside a parameter and you have the company name instead, or something like that? If that happens, or if the value is empty, or if this or if that, then you probably just found your bug. Now, the first thing to do is to verify that you have the correct value when you're entering that code, and then you go at the end of the procedure and you verify that this procedure is returning what it's supposed to be returning. If the answer is yes to both these questions, that code is not the problem. If the answer is no to one of those questions, you've found most of the time where to look exactly. And if you realize that entry values are correct, exit value are not, it's somewhere in between that you have a problem. So at that point you're going to separate your code in logical steps, which should already be done by all the commands and algorithms written in the code, and you're going to repeat the same process. When you arrive at that stage in the code, you're supposed to have this and that in this variable or that variable. When you exit, you're supposed to have this or that. Is it true or not? When it's not, you know that it's between the two. And doing that step by step, you isolate the bug in a smaller code context, and then suddenly you say, oh, but of course it's because, and you're done. And remember one thing, you should not believe. Being a believer is not something that works when you are debugging. You have to verify everything, even the things you know are correct. How many times I've heard somebody saying, oh, I know that this is correct. How? Did you check? No, but I know it's correct. You don't know anything. You're debugging a problem, which means that you have a problem that you don't know where is the cause. And if you don't know where is the cause, you don't know anything. You suppose, you think that this is correct. And that's already bad, but you don't know. So check everything. Check that the company contains the company, that the file contains the file, everything. This process is a mind teaser. It's really the cop looking for who did it. So it's exactly like reading a good book with a police story in it. Enjoy it. It's a mind teaser. If you really follow that process and you do it with the correct mindset, it can even be fun. So instead of being afraid of the debug and being stuck for days, you're going to say, okay, I'm going to find that one. And you find it. You will, if you follow these steps.
Now we're going to talk about the different cases when the debugger doesn't work, because there are several of them. You have to be aware of them, and in order to know when to use the debugger and when to use something else. First, if you use timers, you are out of luck. What happens is that you're debugging a code, and you're in the middle between line 223 and 224, and suddenly the timers fire up. And what happens is that, well, you're suddenly in the code of the timer, and once you're there, the debugger doesn't know how to come back. Okay, you're dead in the water. So if you use timer and you need to debug a code that is not dependent on this timer I use for something else, I strongly suggest that you put the activation of your timers on a switch. Either you don't do the timers in test mode at all, or you have a switch that is written in an INA file that you can set up easily, debug mode equal 1 or 0. And when you do a timer, you do in fact if debug mode 0, then timer. This way you'll be able to use your timer all the time, and when you need to debug, well, you can avoid the problem. Second case is when you're using messaging between windows or even between applications. Messaging is send message and post message. It's advanced programming. Most of you will never need to use that, so it's good if you don't need it. How does that work? Well, you send a message doing a send message or a post message, and on the other side, the receiving window is supposed to have an event set up to start code when this message arrives. So you have exactly the same phenomenon that with the timer, except that you don't know when it's going to happen. It's just going to happen when something else is sending you a message. So that's not good. Of course, you have the second part of the problem, which are the events. If you have code firing on events, and the events are not started by the code you're working on already, but by something else, then you're going to be interrupted again, and the debugger really doesn't like that. Then you have the problem of the multi-application debugging. Okay, what is that? That is a strange case that hopefully will never happen to you. It's when you need two or more applications to work on the same process at the same time. By example, you have one application that does a synchronization process. So it starts a synchronization by creating the synchronization file, or the replica as it's called in WinDev. And then you want to transport that file to the server in order for the synchronization to be done. But you don't want your main application to be stuck with that, so you code that in a secondary application. And this secondary application is going to take the file, connect via FTP, transfer the file, wait for the answer, the replica that goes down to be generated, then take it, do the FTP down, and put it in the directory for the main application. And then the main application has to know that this file is there in order to integrate it. Well, that's a case where you have two different applications, and obviously at some point they have to communicate. So there are many ways for them to communicate. You need to have the main application to tell the other one, okay, send this file and this and that, okay, the file is ready, do it, it has to know that the other is transferring because it has to display the information in its window, and all these wonderful things that crazy requirement will add to your already too big load of work. And of course, when you do that, you have messaging between the two applications, you have something that doesn't work, and there's no way you can debug. You can debug one side, but you cannot debug the other one, and you just have to find a way to really look at what's going on in the dialogue between these two. So in this case, clearly the debugger is not a solution. We're going to talk about the solution afterwards, of course. I already told you about that one. If you put some code in the Windows get focus or Windows lose focus, then you cannot switch between the debugger and the application if you want to look at it and you're on the same window. On the same way, if you put some code in the window change size or window move code, and you want to move it while you're on the debugger, you won't be able to do that either. So it's a good idea, if you don't need the debugger to start during the initialization process, to first put your application at a place where you can see it on the secondary pane if your debugger is on the main one, and then when it's done, to have the debug process starting with everything visible. Of course, there's no way you can debug inside the WD code itself. You're not going to be able to see what PCSoft guys are doing in their code during hread first, table add, or whatever else you can have a problem with. So what you can do, and what I already showed you that was possible and I did myself, is to inspect the parameter of every WD command, WL command, and also the result of it. Remember that lots of these commands are returning a value, and most of the time we are not checking them because we assume that everything is going to be fine. And well, from time to time we have to add code just to check what value is coming back from the method. And finally, of course, and I already told you that perhaps 20 times, you cannot debug inside a SQL query. If you do a wonderful query with 10 lines of code inside the query to get exactly the data that you want, well, you're on your own. Either it works or it doesn't. And if you look at the forum exchange on that subject, you will see that every time you'll see a guy saying, okay, I'm trying to do that and my query doesn't work, and perhaps 1 week later he's going to say, okay, now it's working and here's the resulting query, and you have a wonderful query after 20 exchanges between him and several people who tells him, oh, be careful, did you look at this or did you look at that? That's not a debug process, that's a divination process. And personally, I lost my crystal ball a long time ago, and therefore I'm not really good at divination. I really prefer my good debugger and being able to see step by step what's going on. So again, use hxxx commands. These ones have really a good way of being debugged. There's no problem with them.
So what do you do when you cannot use the debugger? Well, obviously you have to extract information from your code. That's what you're doing when you're using the debugger. Well, the debugger is doing that for you and displaying it in an easy way. If you don't have the debugger, you have to somehow extract the same kind of information. Well, you can display it on the screen, and there are several ways of doing that. You can print it on a printer, or you can log it in a file. That's basically the three things that you can do, and we're going to talk in detail about each of those solutions. The first way to display some information from inside your program is to use the info syntax. It's something that lots of people do. It's the basic thing. You want to see a value, you do an info of that value. But you have to validate each of them. So each time there's something displayed, you have to click or validate. And therefore it's useful only for small problem and certainly not in loops. If you have a loop from 1 to 1000, you don't want to have to click 1000 times to go to the end of the loop. So basically it's something that is extremely limited. The second method that you probably all used already at some point or another is the trace. Trace is a simply way of displaying data. It doesn't stop your process, there's no validation required, it just display information in a secondary window, this wonderful yellow window that we all love. And it's therefore much more practical than info to work in loops and things like that. You can see what's going on during the whole thing. You can also copy and paste the content, export it. The current trace, remember that there's a right click available on the trace window where you can do many things. So it's much more powerful than info for that. It's built for that. So that's already a better way of doing a debug when you cannot use the debugger. But it doesn't work all the time, because it's another window that is coming from the same program. It can make interference with events and focus problem. Remember, the trace window is a window of the same program. It's a sister window, and therefore it can take the focus from your application. At a point where you suppose that your main window has the focus, it's the trace window that will get it, or will take it and give it back. So events and focus problem are not solved by that. So if you're in this case, you can try to build an enhanced trace system. And the way to do that is to, in fact, instead of displaying the trace information immediately, to send it to another program that will be in charge of the display. In that case, you will use message, send message or post message, and share memory to pass information from one and the other. It's perfectly possible, I know, I built it at some point, and it allows you not to have the display done in the same program, so you don't have this focus problem anymore. But it's complex to build, and also it adds messaging and events to process the message, and therefore that too can change the behavior of your program. It will help you a lot if your problem is coming from a focus problem. What window has the focus at which point of the process? But if it's a problem with events and already message, and you add events and message, obviously it's not a good idea. So for those of you old enough to remember the time of the console and the print trace that we had on big system a long time ago, I included this slide because it's true, you can print your information using iPrint by example, but it's going to be visible only at the end of the page, because modern printing under Windows print physically on the printer only when one page is completed. You could also print directly on the printer using SWrite, line by line. So on a matrix printer, if you still have one somewhere, it will display line by line the way this wonderful system was working on the big system a long time ago. but it's complex, and most of the time on current printer it will still be visible only at the end of the page. If you have a laser printer, it will not eject the page till it has the whole page filled. So obviously this is absolutely not practical. It's just memory trip, but that's all it is. The last way of managing information that you have to extract from your program is to log it. You're going to write information in a file, and you're going to display it in another simple application. You could use Notepad to do that, but the problem is that when you add information in your main program, you will not see it in Notepad. There's no refresh method available there. So the best way to do that is to create a very small application that reads a file, and every second or so on a timer go see if there's something new in the text file and just display it. That's the best way to do that. It's basically you just have a program that reads a file and do a trace of each new line in finding it. This method solves the focus problem, because obviously it's another application who has a window to display information, and you will be in that configuration anyway when your program is out there. You will have other applications competing for the focus with your application on each customer system. So if your program does not accept any windows from any other application open at any time, you already know that you are in big trouble. So that is a problem that you have to solve, and that is absolutely acceptable. Also, this system works with timers, multi-thread, multi-application. What do I call multi-application? Well, imagine a system where you have, and yes, of course, that is real life experience again, where you have one main program and one or several secondary programs that have to deal with the main one. By example, one secondary program to replicate information with your replication server. And of course, you want in your main application to have some kind of display of the replication system. You don't want to have that in the background and not bothering you. No, you want to have, let's say, an icon coming from red to orange to green, and a small text saying sending, receiving, done, and so on. You may even want, each time your replication process has been done, to refresh some information, because, well, you can have received some new parameters, and now you have new options available in your menus. That can be that too. So it means that you have to manage communication between two programs. That's one thing, but you also have to debug that process. And now you have things that are done in one program, things that are done in another one, and one very important thing is to know in which order everything is done. Is everything done at the appropriate time? So with that, you just log from both this program in the same text file, and yes, it's possible to do that. You are in fact sharing the text file, and when doing that, you have a perfect on-time description of what is going on. So it's an extremely practical way of debugging in these cases. Of course, this will slow down your app. We talked about that already, I think, and remember that you can always and you should always put that on a test and log only when you need to debug something. It doesn't mean that you have to remove your log lines from the program. You can leave them most of the time, only do not activate them. Very good thing is that it can be used at your customer site, so that's great. Of course, it's a problem that will be less of importance with WinDev 12, because there is the on-site debugging system coming up. and that's going to be great, but even that will not solve the multi-application problem. So you will still need to log in many cases. So it can be used at your customer site. You can have the log turn on at your customers, and you receive the corresponding log after that, and you can study it. So it's practical. Another thing that is good is that you can compare that log with another one that you do yourself, and you see what the difference is, why it's working on your place and not on the other. So all that can be extremely powerful. But be careful about what you log. Do not log passwords. Of course, when you want to log something that is coming up in a method or a procedure, the first thing that you want to log at the beginning is the value of the parameters that are sent in. You need to know if the parameters are correct or not. Well, yes, but you don't want to log the password. You do not want to do that. And it makes you laugh, I'm sure, because nobody would do that. Well, actually, yes, I've seen it. I've seen the log file, and in it I would say, okay, password, that's not good. So just remember when you're logging that your log line is going to stay in the file and go to your customer, and if you have to do that, suddenly you have the username and password in clear in a text file on the disk. So be careful what you log. Let's have a look at the plumbing. In the help file you have information on how to log information when you cannot use the debugger. The first thing that you can look at is Debugger, debugging without debugger. That's in the help file, and we're going to have a look immediately. As you can see, it's in Debugger, debugging without debugger. So, what are they telling you? Let's see if they agree with what I told you. Well, in some case, running a program with debugger can produce different results. Okay, we saw all that. So, to debug this application, you may want to display on screen or store in a trace file. That's good. They are telling you how to do it. How do I proceed? So you have the info, the trace, and so on, and now managing the display of the debugging information. Well, what you can do, they're telling you a procedure called myTrace, and in that, if you are in test mode, you do the trace. So they are telling you the same thing that I did. Don't leave your trace in the program, don't leave your log in the program. Now if you want to create what I call a trace file and what I call a log, then they are telling you to do the following thing. In your trace procedure, if you want to do in a file, then you do an fopen of the file, and after that you write lines in it. So, as you can see, you already have in the help file the code necessary to do that. That's what it is. Okay? So it's very simple. Now just forget about it. And why? Well, there is much simpler than that, and it's also in the help file. Look at the start trace option to write in a file. Let's have a look. Coming here, start trace, Okay, start trace has the option, as you can see here, to write all information that is displayed normally in a trace in a log file. That's an option that is quite new in within one, but now you have even the possibility to display in a window and to log in the file. But what interests you here is to do this. So start trace in the file, and you tell the system where to write. And that's all. After that, each time you do a trace, it's working. It's one of those cases where a new functionality appeared in WinDev, and well, it make it to the help file, but they forgot to change information that was somewhere else about the old way of doing things. So that's why I wanted to show you these two things in the help in order for you to start with the right thing. The simplest way of doing that is to use this simple start trace, tr file, and the path of the file. Be careful where you put your file. Remember, in Vista you cannot write everywhere, so it's a good idea to use here the get data dir from your CL project class that will return you something that is adapted to your operating system. It's time for an example. As you can see, we're here in WD Slow again, and in this version of WD Slow we have these two trace buttons that I added. We are now going to have a look at the first one as an example of what we just saw. In this trace button, the only thing I'm doing is opening a WinTrace window, which is already here. As you can see, very simple window again. So what is available in this window? In the window initialization code, you have this start trace. You remember this instruction I told you was the best way of doing things. Well, this one is set up to write in file and in the window at the same time. And it's writing in a file that is in the exe directory of my program, which is, remember, not a good idea if you're running Vista. So on Vista you will have to do something else. We'll see that later. And it's writing in a file called test.log. So after that I have an edit field where I can enter the information I want to be logged. That's in order to simulate what you would have in your code with a string that you log this way or that way. And then the start button. The start button, which is an on-off button, and where I use this property to change the label to stop and start in order to be able to do exactly that, stop and start the process. And it's just calling a procedure called loop on trace, in which I'm doing a loop, and if the label of the button is stop, the caption of the button is stop, then I'm just I know that I'm running the trace currently, so I'm just tracing the value of my field and the current time. And if it's start, it means that it's the I ask to stop the thing, and in that case I'm adding also the stop to see where's the end of it. And then I'm doing the multitask in order to let everything display on screen, write in the file, and so on. That's all there is to it. Let's try it. I will just run it. Go in the trace. Here we are. As you can see, the trace window opens immediately when we reach the start trace, and we are going to do a first test here. I'm going to start it, wait a few seconds, then stop it. I won't talk during this time because the processor of my machine will be busy processing the trace, and because of that the recording would be bad. Here we are. As you can see, we had this trace on the screen with my text and the timesys and the stop when I clicked. Remember also that you have the possibility in every trace window to do a right click and to have this copy all, save as, clear trace, topmost, save size and position, horizontal scroll bar, accept control character, all these settings that will be remembered for your trace window. So that's very simple on screen. Let's have a look at the file itself. I'm going to close all that, and we're going to have a look. Because I was in test mode, the exe directory is in fact the exe directory of WD test, and the directory I have to look in is the programs subdirectory of WinDev 11 US. So here I am, and I want to look at the test.log that was just created. As you can see, it's 1 kilobyte, and if I open it, I have the exact same thing that I had in my window. Very easy, nothing to it. I was telling you that this system works also when you want to debug several programs at the same time, programs talking to each other, by example. And I'm going to demonstrate that by using the WD Slow exe version this time and starting it twice. Here's one. And here's two. So we have these two programs. Let's use the same window, trace window, and we have the trace here. We are going to reduce that in order for it to be usable. Here we are, and we're going to do a trace here. Okay, and we are going to again reduce it to be usable. So now I'm in the situation where I have two programs. Here it's the same one, but obviously it would be more two different programs talking to each other. So here I'm going to say this one is the first program. This one is the second program. And I'm going to start and stop repeatedly these two trace system. During this time I will not talk again for sound recording questions. I will just do that for a few seconds, and you will see the trace going on one side, on the other, both at the same time, one stopping, one starting as I click on the buttons. Here we are. As you can see, nothing special, just start, stop several times, and each program has its own trace window. In each there's only one program recorded. So now we're going to close all that and have a look at the corresponding file. This time, because we are in executable mode, the log file was created in the WD Slow exe directory. And this is the result that we have. As you can see, the first program starts alone here. Then I start the second program, and at that point I have second program, second, first, second, second, first, second, first, second, first. Both these programs were doing the exact same thing. So you would think that each of them would use the same time to do the same thing. Well, that's not always the case. As you can see, one write, the first one, the second, the first, then twice the second. And this is an example of the kind of thing that you can see only if you log in the same file. At that point I stopped the second program, so the first was logging alone. Then I restarted the second program, and so on. And you can see this way how handy this system is when you would want to debug a dialogue between two programs. Is the program doing the right thing when it's receiving something? Is it receiving something at the right time? Is there a delay? Is there... all that can be seen very easily. We now have a reliable method to log information in basically all cases. It doesn't matter if it's one program, two programs, three programs, if it's multi-threaded, if it's events or anything like that. You can always log in this file. It won't create a problem, except of course slowing down your application. So the question is, what do you want to log? How are you going to use that system in the most efficient way? Well, let's have a look. You have, first of all, to choose a file format. What do you need to log in your file? Well, obviously, if you are doing multi-program logging, you need the name of the program, but that's not the most often case, hopefully. So, most of the time, what you're going to need is the date, the time, the name of the code. So first, let's see, why do you need the date and the time? Well, you want to know when that log file was done. If you continue to log in a file, you'll be happy to know that this log information is the information that was written 2 days ago with the old version of the program, and that you don't have that same problem now. So that's also very helpful to compare things that were done at different date and time. So it's something that you definitely want to have. It also gives you an idea of how long a process takes. If you have one log at the beginning of a function and another log at the end of the function, you know that this function was done during that time. That's the same thing that the profiler is doing. You're not doing it to do any optimization, you're just doing it to debug, but it helps too. Then of course you want the code name. There's nothing more frustrating than to have a log that says problem doing this or that, but you don't know in which code, in which procedure, in which method the log was done, and it can be from 5 different places. So that's a very important thing, the name of the code that is doing the logging. Of course, you also want the parameters value. If you are entering in a procedure, you want to check that this procedure is receiving the value it's supposed to receive. So you want to log that, except of course when it's the password. Then it's also a very good idea to log whether you are entering or exiting a procedure. You don't want just to have one line in a procedure or method that is called. You want one when you're going in and one when you're going out. This way you know that you went out correctly from the procedure. And you also want very often to have the level. What is the level? Very often in our code we are playing with Russian dolls. We are calling a method that is calling a method that is calling a method that is calling a method. And it's interesting to see that you are all doing all that in the right way. I've seen cases where I had this strange behavior in the program. I didn't know what was going on. And it was this kind of random error, not always the same time, the same way. And we didn't have any explanation till we added this level in the log. And at that point we were able to see that the program was calling another one, another one, another one, another one. And then for a strange reason we would be passing from the level 7 to the level 4 without ever exiting the 7, the 6, the 5, and suddenly we're in the 4. Why? Well, we had to find out. It was basically because we were closing the window that had called the method, that was calling the method, that was calling the method, that was calling the method, and in that we were closing the original window. And suddenly we were in fact sewing the branch on which we are sitting. That's something that you should never do. And when you're writing something that is extremely complex, with wonderful UI, windows in every direction and so on, that's something that can happen. And that's where the level information is extremely interesting. And now, since not so long ago, PCSoft added an extremely interesting instruction in the W language called Debug Info. That Debug Info is a wonderful, wonderful thing. The Debug Info is a call that allows you to get basically all the information that are in that stack part of the debugger window. Here is a list of the parameters that you can send to that instruction in order to get different things. What can you get? The caption of the process currently run, which means it's the name of the code I was telling you about. The caption of the calling process, which means that in any place in the program you can know that you are in this procedure and that you were called by that procedure. Caption of the integer calling process. Remember the Russian dolls? Well, you can find out who is calling your process, or who is calling the process that is calling your process, or who is calling the and so on, just by giving a new value to the integer here. Then you have the full name of the process currently run. The difference? Well, instead of having my procedure name, you will have my window.myProcedureName. So that's more complex. And then of course you have the same thing for the calling process and for each level of calling processes. Then you have the number of the current line in the process currently run. That's an extremely interesting thing when you are logging possibly the same thing at different places in the code. You will know that your log is from line 23 or 274. That's a very interesting thing again. It can be also the number of the line where an error occurred and that you're logging afterwards. It's up to you. You can use it both ways. Same thing, the number of the line in the calling process. You can have the same method called from the same calling process at different places. And this allows you to know which of it was the call that you are currently in. And of course, same thing for each of the previous calling process. And finally, you have the possibility to get the whole stack of the calls. As you can see, it's really the information that is available in the debugger now available for you when you don't have the debugger available because of what you're doing. It's extremely powerful and it gives you a lot of information. So depending of what you're doing, the kind of program you're using, you will use one of those to know what's going on. That's the first part, is really deciding what you want in your debug file. I strongly suggest that you put all this information all the time, even if you don't think that you need them currently. That will allow you, when you start to have problem, not to have to change your whole debug system, but continue to use it. If it's powerful enough at the beginning, it will be the same thing that you use for years. I chose to implement this log system in a class called CLLog. It's very original. And this class is part of the project that you will have on your DVD. So you will be able to use it directly in your project if you choose to do so. Why in a class? Well, first reason is that everything is in the same place. You just take the class. It's very easy to integrate in any project. The way it's coded means that it allows the log code to stay in the project. You don't have to do anything specific. You just put your log code and you activate or deactivate the log depending on what you need. And of course, this class also allows the code to be used at the customer's place. The whole class is written that way. And again, there's a trick used in that class in order to allow you to track entry and exit of every procedure very easily. Do not be afraid by the fact that it's a class, even if you're not familiar with object-oriented programming, and you will be familiar with that at the end of this WinDev course, of course. But even if you're not really familiar with object-oriented programming, the only thing that you have to do here is to learn how to call it. how to use the class, not how to write it, because the class is already done. So that's what we're going to have a look at now, how to use that class. The first thing that you do with that class is that you set the log mode either during the project init or anytime you want. What do I mean by that? Well, I mean that you decide if you want to have your log active or not, if you want to have the log doing this or that, and this allows you to let all the log code inside your classes, your windows, everywhere. And if at some point during that point and this point, between these two parts, you need to have the log on, you just add a set log on, set log off, and it will log only there. You can also have INI file or registry setting that tells you log in this mode, that mode. It's very easy to do. In order to log a simple line, you will use a global call, and if you don't know what a global call is currently, it doesn't matter. You will just have to learn the syntax to use. There's nothing to it, and then you'll copy and paste it everywhere. For those who know what a global call is, well, it's just because this allows to log even before declaring any log object. So everywhere in the project, log is available. And then when you want to track the entry and exit of a procedure easily, you just have at the beginning of each of those procedures to declare a log object. Because of the object, again, if you don't know how it works, this static object that is declared in a procedure will have a lifespan that is the same than the procedure, which means that the constructor will be called when the object is created at the very beginning of the procedure, and the destructor of the object will be called when you exit the procedure, and it doesn't matter if you have one exit or 5 different exits with 5 different results in your procedure. Doing that, it allows to log information in the file in the constructor of the object and in the destructor, which means that if with one small line at the beginning of your procedure, you are tracking the entry and exit very easily and automatically. And the class will also manage the level for you, because it will keep track of all this entry and exit. So that's already done, already built. The logic is working. I've been using that for a long time. We are now going to have a look at the code itself.
We are now looking at the WinTrace2 windows of WD Slow. It's the window that is called by the second trace button in the main WD Slow window. And basically it has the same feature than the first WinTrace window. You have still the trace field in which you can enter a value to be traced. You still have the trace button, the start button, still a start-stop button. And then you have a test2, a mode, and a log is on or off control. That's all. The main difference is how things are done. In this window we are using the class that comes with the course. So the first thing is to look at the initialization of the window. Before we were doing a start trace with the file and directory set, and this is replaced by two calls to the class. The first one, as you can see, it's extremely simple: cllog : set mode. Cllog being the name of the class. It's a global call for those of you who already understand a few things about object-oriented programming. So, is setting the mode for all the following calls. Here I'm saying that it's in a file, and again I'm giving the complete directory and name of the file that I want to log in. I created that class with an either in a file or on the screen system. I didn't use the file plus screen system because I didn't need it. Of course, if you want to implement a new option that is both, you can certainly do that very easily. It's just a small modification. Then there is a second call also to cllog : set log on. This is the call that will activate the log. Why do I need two different calls to do what was done in only one before? Well, it's because I wanted to be able to set the mode immediately, but to start and stop the log by itself only when I needed it. And I didn't want also to have the log be set to on by default. So the default when you start a program is that the log is off, and explicitly you will set it on when you want to. This is because I'm used to leave my logs, many of them at least, in the program, all the logs in the methods and all this kind of thing. And I certainly don't want the program to start logging like crazy as soon as there is a set mode done somewhere. So I really want that to be done only explicitly. Now let's have a look at the button start itself. This code is exactly the same that it was before. There's no change here. The only change is in the loop on trace. We are still doing a loop. We are still doing different things depending if we're in the start or stop mode for the button. And the only difference here is that instead of doing just trace edt trace plus timesys, we are doing cllog : trace. The advantage of that is that even if you are already using traces in your project, you can just do a find and replace of all the traces and put cllog : in front of the trace, and you're good to go. You're using the class instead of using the regular class. So it's very easy to do. We are now going to test this system. In executable mode, we have our WD slow UI. I'm clicking on trace 2 and I have my window. So here I'm going to do that using with the class tag, and I'm just going to start and stop to show you what it is. And you didn't see anything. The reason for that, remember the source when we are doing the window initialization, is that this source log in a file. And that's what you can see here. That's the default for this window. So if I want to show you something, I change it here on screen, do a start stop again. I'm increasing the size of this window in order to see that in a better way. So what do we have here? We have, of course, the date and time separated by tab. Remember that you can also here accept control character, and in that case you will see this. But I do like to see the control character precisely because here it allows me, sorry, now that it's done like that it doesn't come back. I'm just going to start it again. Allows me to see that here I have two tabs, one after the other, which wouldn't be visible here. I don't see that there's one or two. So what do we have? Date, time, and then we have this 0 value all the time. We'll look in detail to that column afterwards in the second test. Then we have these two empty these two tabs, which mean that there's an empty column here, and again we'll look at that later on in the second test. And then we have my tag with the class and what I was logging here, which is the timesys. The main difference between what we had before and what we have here is that it's much more readable. Remember, we had this timesys, now this is the corresponding time. It's clearly a better way of displaying things. Of course, we can see the same thing in the file, and to do that it's very easy. Just going to close that and go in the corresponding file. It's here. You remember that it's what was logged by our first test a few minutes ago, and now we are looking at the difference between the log that we had using just the start trace and the log that we have with the class. If you don't think that the second method with the class gives you a result that is much more readable, much more easy to use, and much more powerful, then don't use it. But I think that there won't be a lot of people who will agree with you. So we have exactly the same thing here in the file. If we now look at the second test button, we can see that the content is quite different. In the first one we had this cllog : trace called in the procedure. Here, what are we doing? We are creating an object of the cllog class. That's the other method of doing things. So we are creating an object that is called cllog, and in it we are first passing where we are, one from button 2, okay, and then we are passing 2, 3, 4 values. That's just an example of the fact that you can send several values, like the parameter that you would have in a method or procedure, and this value can be string or integer, doesn't matter. All this is things that you can pass to the method. Once this is done, we are calling a procedure. If we have a look at that procedure, just a call, again we are creating a log object local to that procedure. Of course, it's static. For those of you who are still seeing the difference, for the others, we'll look at that in detail in the object-oriented programming course. Here's the call from the procedure, and we are just calling another one. This one was a local procedure. Just another call is a global procedure, in which we are again creating an object of the cllog class. Of course, in each and every of these procedures, we would normally have code that is executed. Here it's just an example of the log functionality, so I didn't need anything else. And now we are going to test that that button in the executable. So we are going and trace 2 again. I want to see that on screen in order to be able to show you what's going on. So I'm asking on screen, the log is on, and I'm just going to click on test 2 and stop it afterwards after a few seconds. That's it. I didn't have to stop it, in fact, because it's not in a loop, it's just doing its thing and stopping. So let's have a look at what we have here. Well, we still have the date and time, of course, but now we have this column that was at 0 all the time, which is in fact the level column I was talking to you about in the theory part of this course, and this level is 1, 2, 3, 3, 2, 1. Why? Well, because the class is able, when you're creating objects like that, to keep track of the level at which you are creating the object and destroying the object. So the level 1 obviously is the button test 2, and that's what we have here, button test 2. The second level is the just a call. The third level is just another call, the global procedure. And then we have the exit of just a call. As you can see here, we have just another call, exit off. We have the exit of just a call at level 2 and the exit of button test 2 at level 1. But the only thing that we did in this free code, I didn't hide anything, is creating one object at the beginning of the procedure. And that is the neat trick I was telling you about in using a class to do this kind of thing, is that when you create an object, you have the possibility to put some code that it will be executed when the object is created and when the object is destroyed, which happen automatically for a static object when you exit the corresponding procedure. And automatically the class for you is going to keep track of the moment when you exit the code. The class is going to calculate the level all the time, And if something is missing, if we had it here by example 1, 2, 3, 1, it would mean that we have a problem that happens at that moment, and that problem most of the time is that in this third call you would be perhaps just closing the window that was calling all that, and clearly that's not something that you should do. So this level thing is extremely important when you have a complex UI. And this part, as you can see, the WinTrace button test2, WinTrace2 just a call, global procedure WD slow just another call. We didn't log all that. You've never seen me writing all that in the code. That's the debug info information that I was telling you about, and it's the name of the code it's the full name of the code. So it's the button in that window, it's the procedure local to that window, and it's this procedure which is in the global procedure WD slow. So all that is done automatically. You don't have to do it by hand, and the trace is just doing that very easily. Of course, if we would do that in the file, we would have exactly the same thing. Okay, I can go now in the file and we would see that we have at the end the exact same thing with the level 1, 2, 3 and the information. So it means that if you write a small program that just read this, and because you have the level, you can indent what is going on in order to see things better. And if something is not correct, if something is missing, you can automatically detect it and put everything after that in red, because, well, obviously the exit of the procedure is missing. Something went wrong at that point. You can much more easily find out where you have this kind of big problem. What else is there to see? Well, not much, because we're not going to go in the details of the class at that point. We'll look at that later in the object-oriented programming course. We're just going to have a look at how you can use it. We already know how to init the window, init the trace. We know how to log. The only thing that remains is the mode and log on or off. In the mode, we just have this, depending on the state of the radio button, we are setting the mode as file or trace. That's all, nothing to it. And in the log, we are just calling set log on or set log off. And that's it. And basically in the CLLog class, that's all you have. If we just want to have a look at the class itself here, in CLLog we have the set log off, set log on, set mode that are used to set how the class is behaving. Then we have the trace global method to log directly one line anywhere. That's what we are doing in the first test. And then we are just also creating objects, and that's why you have the constructor and the destructor, in which log is done automatically. And that's it. With these 5 different things, you have a full log and trace system. And of course, this class is coming with WD Slow project. It's on your DVD. So you are now able to use that class directly in your project. You are free to use it. You can of course enhance it, modify it, do whatever you want with it. It's there for you to use. I hope you'll enjoy it and you'll use it with as much profit I did. And well, that's all there is to debugging without Debugger.